Alright, this is 7.5 Form G. I'm going to do number 16 here. This one requires both your need to FOIL or use the box method, and then also factor to get your solution. So let's go ahead and get it set up. Like I've been saying before, there's 3-4 different ways to set these up. As long as you're consistent, it doesn't matter which avenue you take. I'm going to compare 3x to x plus 4, which would then require me to compare x minus 1 to x minus 2. Okay? So the one thing that's important to do, again, whenever you're dealing with binomials in your proportion, is to put them in parentheses. Okay, and actually before I get started, I'm going to go to a new page so I have plenty of room to do the work. So let's copy down my setup here. I had 3x is to x plus 4 as x minus 1 is to x minus 2. So again, make sure you put all of your binomials, anything with two terms, in parentheses to remind you to distribute when you cross multiply. So if we do our first top left to bottom right, we get 3x times x minus 2. And then your others will be x plus 4 times x minus 1. On the left-hand side, we distribute the 3x through, we get 3x squared minus 6x. That's easy. Okay. The right-hand side, on the other hand, you have two choices. You could FOIL first, outer, inner, last, or I think a lot of you guys are starting to get comfortable with what I call the box method before we took our little break. So when I do this, I just write my two binomials, one across the top, one down the side. And to get the value on the inside of the box, you need to multiply the two terms that are touching that part of the box. So x times x gives you x squared. Negative 1 times x gives me negative 1x. Top right, x times 4 gives me 4x. And bottom right, negative 1 times 4 is a negative 4. When you do this, the terms on the bottom left and top right will be your like terms. Your x squared and your constant will not be like. They will be the ones that are left alone. So x squared, combine these terms, negative 1x and 4x gives you a positive 3x minus 4. And bring down what I had from the left-hand side. So I have 3x squared minus 6x is equal to x squared plus 3x minus 4. Now, I got to factor. I know that because I have x squareds in my equation, and I need, in order to factor, to get all of my terms on one side of the equation. So you have choices. You can move all of these terms to the right, or you can move all of these terms to the left. And again, the way I make my decision is I want to make a decision based on my x squared term. So I'm going to move the terms to whatever side keeps that x squared term positive. So that means I'm going to move x squared over to the left. That way the x squared becomes or stays a positive. So I'm going to minus x squared from both sides. I'm going to minus 3x from both sides. And I'm going to add 4 over here too. And there's really a plus 0 here, so just so you know where that's all going, you got to keep your x squared, your x's, and your constants all together. So everything over here cancels out. We got 0 over here on the right-hand side. 3x squared minus 1x squared gives you 2x squared. Negative 6x minus 3x is minus 9x. And 0 plus 4 is simply just positive 4. Okay? So in this case, when you were in Algebra 1, every single time that you did an AC grouping problem, you may have had a greatest common factor, but your A term always ended up being 1. Well, this is not a case where that's going to happen. Okay, in this case, if I were to check for a greatest common factor, there doesn't exist one between 2, 9, and 4. So there's nothing to factor out. Okay, so now all I do is I just multiply my A and my C term, which give me 8, and I'm going to list all my factors of 8. I need the pair of factors of 8 that will combine to give me this middle term of negative 9. And again, you have the liberty to make whatever terms or term you need to be negative to give you negative 9. Well, in this case, 2 and 4 aren't going to do it. But if I make both the 1 and the 8 negative, that will add together to give me negative 9. So I'm going to rewrite this part of the equation, okay? But I'm not going to write negative 9x anymore. I'm going to replace it with negative 8x and negative 1x. So if I rewrite that, I get 2x squared minus 8x minus 1x plus 4 is equal to 0. Okay? Now, in this case, I have my 4 terms, so the AC part was to multiply these two numbers to get 8. The grouping part is to put the 4 terms into groups of 2. Now, within each group of parentheses, I need to check for a greatest common factor. So if I look in this first set of parentheses, the greatest common factor between 2 and 8 is 2, and the greatest common factor between x squared and x is x. So I divide everything in here really by 2x. That gives me, 1x minus 4. All right. Now, as I look at my other term, there's really nothing to factor out. And let's just pretend hypothetically, let's say you made this mistake. Let's say that you factored out just a 1, and you were left with negative x plus 4. Well, when I get to the step, this and this have to be the exact same, and they're not. Okay, so that tells me I've made a mistake. So what you need to do for this is you need to factor out a negative 1, leaving you with x minus 4. Now, these two terms match, okay, which means that you are on the right track. So, x minus 4 is one of your terms. You factor that out, and what's left over is your 2x minus 1, and we're still equal to 0. So, set up your two little mini equations. Alright, so on the left-hand side, I'm going to add 4 to both sides, and x equals 4. On the other side, add 1 to both sides. 2x is equal to 1. And I'm going to divide both sides by 2, and that tells me that x equals 1/2. Now, you look at the answer key, and you're like, alright, well, the answer key says that the answer is only 4. Why is that? Well, if I take the value 4 and plug it in for all of these values of x, they always give me possible solutions, right? This would give me 2, this would give me 3, this would give me 12, this would give me 8. Okay? So that's all possible answers because they're all positive values. If I take a half, on the other hand, 1/2's good here, 1/2's good here. 1/2 is not good here. That gives you a negative value. 1/2 is not good here. That gives you a negative value. Well, not negative 1, but it gives you a negative value, right? So negative is not a possible answer for a length, right? So anytime you have a negative answer, that tells you that solution is not possible. So 1/2 is no good. Only 4 is the solution to that equation. Any questions? Shoot me an email, slandere@nhsd.net.